So now that we know when we have a slant asymptote, let's talk about how to calculate it. In order to identify what our slant asymptote is, we have to do polynomial division. This is the exact same algorithm as long division of normal numbers, where you have a dividend that's divided by a divisor, producing the answer, a quotient, plus some remainder that we'll use for the rest of these problems. So let's look at the same problem as before. We're looking at 3x squared minus 2x plus 1 divided by x minus 1. We'll notice that the degree of the numerator is 2, the degree of the denominator is 1, and sure enough, the degree of the numerator is exactly 1 more than the denominator, so we know that we will have a slant asymptote here. If we want to divide these using long division, we can set up our algorithm the same as before with a 3x squared minus 2x plus 1 as our dividend and x minus 1 as our divisor. We'll note that it's important to write these numbers in descending order of exponents. And then we just look at how many times x minus 1 goes into 3x squared. Really, we just care about how many x goes into 3x squared, and it goes into 3x squared 3x times, since 3x times x is 3x squared. Then we multiply these two things together, giving us 3x squared, that's 3x times x, minus 3x, that's 3x times minus 1, and we subtract. 3x squared minus 3x squared is 0. Negative 2x minus negative 3x, that's negative 2x plus 3x, is 1x, and we bring down the plus 1. Then we repeat the process. How many times does x go into x? Well, it goes in 1 time. 1 times x minus 1 is x minus 1, and x plus 1 minus x minus 1, x minus x is 0, 1 minus negative 1 is 2, and so we can say that 3x squared minus 2x plus 1 divided by x minus 1 is the equation 3x plus 1, that's our slant asymptote, with a remainder of 2. We'll talk about how to rewrite that in class. Speaking of class time, we will learn an alternative to long division called synthetic division, which is a simpler and shorter way of writing this. And we'll also talk about how to visualize and graph our slant asymptotes.